let's review why A times quantity B plus C equals AB plus AC is true. We don't want to just say this is the distributive law. We should draw a picture that looks like this. So first of all, consider this big rectangle. I know it looks cut up into two smaller rectangles, but there is a big rectangle out here first. And the width of the big rectangle is B plus C, because adding is gluing sticks together. And the height is A, just because A was labeled there in the diagram. So the overall area, which is the portions shown in yellow, so both of the pieces all put together as thinking of it as one big rectangle, is A times quantity B plus C, because multiplication is the area of rectangles. Now, the other thing we can do is that notice that the big rectangle occupies the same space as two smaller rectangles, and the smaller rectangle, the little one on the left that's kind of in a tan color, has area AB, and then the bigger rectangle, not the big rectangle, but of these two smaller rectangles, the one that's considerably wider has area AC, the blue one. And so the total area is AB plus AC. Remember, the big rectangle occupies the same space. That same space is key for having this equals right here. Right? So we've accounted for the area of the same region two different ways, and so A times quantity B plus C equals AB plus AC. This is going to be considered the only valid explanation following our class standards for why this formula is true. Now we can look at another formula that's similar. This is an expanding formula, or some people call it FOIL because of the first outer inner last. This would be a picture that would do it, right? So the large rectangle has a height of P plus Q and a width of R plus S. So the area is P plus Q times R plus S. And then the individual little rectangles, right? So the large rectangle can be split up as four smaller rectangles whose areas are PR, PS, QR, and QS. And if we add those four together, that's also the area, right? So again, a picture is going to be the only accepted explanation. Now, since we know that this distributive law is true, let's apply it. Turning A times B plus C into AB plus AC is called distributing or expanding. And then going in reverse is called factoring. Same deal with the second formula we looked at. Turning the product into this sum, PR plus PS plus QR plus QS, is called distributing or expanding or foiling. And in reverse, this is also called factoring. It's a little unfortunate that it goes by the same name. There are also extended versions of A times quantity B plus C equals AB plus AC. For example, A times quantity B minus C equals AB minus AC. Or A times quantity B plus C plus D equals AB plus AC plus AD. And you can switch the order, right, of your multiplication. So you have B plus C quantity times A equals BA plus CA. So the variable that's outside the parentheses, in this example in A, appears after instead of before the parentheses. Okay, this is, by the way, allowed because x times y equals y times x.